we can state the division algorithm thus. Let a and b be whole numbers and b not be 0. Then there is a unique whole number q, we call the quotient, and a unique whole number r, called the remainder, such that a can be written as q times b plus r, where r is some number between 0 and b. It is common to write a divided by b as q with remainder r. Conceptually, by using repeated subtraction of b, we have a process that gives us the quotient and remainder of a by b. So for example, 27 divided by 6, I would start with 27, minus 6 is 21, minus 6 is 15, minus 6 is 9, minus 6 is 3, and at that point I would stop because any more subtraction would put me in the negative numbers. So what I have here is 27 divided by 6. I can subtract 6 4 times, and I have 3 left over. So 4, remainder 3. On a larger scale, we have the scaffold algorithm, which is basically doing the repeated subtractions, but on a larger scale. So for example, if I want to do 886 divided by 27, I would write it out in the long division form you see here. And then I ask myself, how many times does 27 go into 886? And just take a guess, make sure you're low. Doesn't really matter. In this case, I'll choose 20. And well, 20 times 27 is 540. So I'd put the 540 right there and subtract. 886 minus 540 gives me 346. And now I'll repeat with the 346. How many times does 27 go into 346? Well, 27 times 10 is 270, so that should work. So let's guess 10. 10 times 27 is 270, so put that there and subtract. 346 minus 270 is 76. And now I do this again. How many times does 27 go into 76? And I'll guess twice. 2 times 27 is 54. If I subtract, I get 22. And now I can't subtract anything more, so that's where I can stop. So I add up my guesses. 20 plus 10 plus 2 is 32. And my remainder is 22. So 886 divided by 27 is 32, remainder 22. What if we want to do 2,245 divided by 38? Well, I know 2,000 divided by 40 comes out to be 50. So let's start there. I take 50 times 38. Well, 5 times 38 is 190. And I'll tack on a 0, so 1900. And then subtract. So I will have 5, 4, and then 345. And so now I ask, how many times does 38 go into 345? Well, it's less than 10. I will say, let's just say 8. So 38 times 8 is 64. And then 24 plus 6 is 30. So that's 304. And so that subtract, I'll get 41. So I can do one more. 1 times 38 is 38. And now I can't do any more. So if I add these up, 50 plus 8 plus 1 is going to be 59. And then the remainder is 3. So 2,245 divided by 38 is 59, remainder 3. Now the more traditional compressed algorithm is to be a little bit more exact with your subtractions. You just take it 1 or 2 digits at a time and then carry down the next digit over. So I start off 27 goes into 88. There's like 3 times. So 88 minus 81 is 7. And then from there, I'd bring down the 6. 27 goes into 76 twice. So I put a 2 on top. 2 times 27 is 54. Subtract, get 22. So 886 divided by 27 is 32, remainder 22. And likewise, if I want to do 2,245 divided by 38, well, let's see here. 38 does not go into 2, does not go into 22, does go into 224. So let's start with that. 38 is about 40, so I'm going to go ahead and guess. See, I know 40 times 5 is 200, so let's start with 5. 5 times 8 is 40. 5 times 3 is 15, plus 4 is 19. So 345. And then let's say 9. So I go 9 times 8 is 72. And then 9 times 3 is 27, plus 3 is 347. Wait. 9 times 8 is, oops, that should be a 2. There you go. And so now if I subtract, I end up with 3. So 59, remainder 3. And that should match what we got before, 59, remainder 3, both ways.